up to -100. Hello and welcome back to Calculus 2. This is length of curve with revenge or something. It's part 2. We need to do those spicy problems I promised last time. We did only one example. The whole section is a way to use integrals to compute length of a curve. So function is going to be some kind of a curve above x-axis, and you can pick A and B points and compute the length of that curve. Now this was the derivation. There was the formula in terms of dx and in terms of dy. And we had one example. It was a very simple example because we could have done this in many other ways. You could have, since you have the interval on x-axis, you can compute the points. You can use Pythagorean theorem. There are ways to compute for the straight line, but we want to work with curves and see which way we can calculate length of curves. So the procedure, as you can see in the formula, is very simple. You have some kind of a function, the curve, that will be your f of x. You're supposed to take its derivative and square it, plug inside that square root, and then work your way through integration. So it's only one formula, and if you were wondering if this formula makes sense, well, of course it does. We'll have to talk about it. You are used to calculating areas, right? You're used to calculating areas using the integral. But now you have length. Length is one-dimensional, right? So it sounds that it's like off. Something is wrong, right? But actually it's not wrong because you have the derivative within the integral. So roughly, the square root and square cancel each other out, and then you have derivative canceling the integral, and you are left with one-dimensional entity. So when we were talking about areas, why are these colors here now? What happened? Now I have to fix all of this. Red, darker green. This red? Yeah. Why?
The rainbow.
Oh, that's kind of cool.
Is it cool?
Yeah.
Okay, the rest of Calculus 2.
No, because I printed. And it's all my stuff. No.
You are the one who wanted it, so this is the rest of your Calc 2 now.
Cool. I didn't say anything else.
All right. Oh, we can do the wood paneling. Here we go. How about this? Better? All right. So when you find an area using the integral, and we'll talk about this at the end of the class today, again, you have f of x times dx. And you can see that technically you have y times x, which is two-dimensional, and that's why you do get an area. Now, with length over here, you must, lose one of these two, and clearly you can't lose dx. So integral square root of 1 plus derivative squared dx. And as I said, square root roughly cancels the square. They don't, but roughly they do because of 1 plus. And then you have integral of the derivative. Now, integral of the derivative, if you remember your fundamental theorem of calculus, it said when you have the derivative of the integral of some f of t dt, you get f of x on the other end. So you get, and this is just y. It's a one dimension, so it's length. So when you look at the way the formula is structured, it does make sense. It is one-dimensional, And you will have much more of this to worry about once you go to Calculus 3, because you will be setting up a double integral for either area or volume, then triple integral for volume or bulk, and so on. So there will be a lot of dimension chasing once you get there. But for now, we just want to, for those of you wondering, how come we are using integral to figure out the length when integral is supposed to be for the area? Well, because there is derivative present, we actually lose one of the dimensions, and there we go. All right, now let's take a look at some of the problems presented in the book. We will start with problem 12. It looks really good because it has ln x in it. And I know how much you all love ln x. There's a sigh of joy. X squared over 24 on interval 1, 2, 6. So this is problem 12. And in order for us to use the formula, we are supposed to take the derivative of the function, square it, plug in, add 1, and then grind through the rest of the calculations. So we start with f prime of x is equal to 3 times 1 over x. The derivative of ln x is 1 over x. Minus the constant is 1 over 24. Copy that, and derivative of x squared is 2x. So now to clean this up, we have 3 over x minus x over 12. So this is the derivative. The derivative is 3 over x minus x over 12. And this is what we are going to add to the, inside the square root. We add this to 1, and we can go from there. So L is equal to integral 1 to 6. That's provided. The limits of integration are provided in the interval. And now we have our square root, 1 plus, and I have 3 over x minus x over 12 in parentheses squared dx. Don't forget to square this. It's f prime squared, right? It's not there for decoration. So now we need to integrate this. And let's see what is the way to integrate this, since we didn't have the chapter on integration techniques yet. So let's see if we can figure something out. So yes, we are going to work this out. So 1 plus, we have 9 over x squared. And now, if you remember, here I'll write the formula. It's a squared plus 2ab plus b squared. Well, we have a minus, but that's okay, right? So we have to now multiply these two and double it. So when I multiply these two, x and x would cancel, and then 3 and 12 would cancel. So I would have negative 1/4, negative 1/2, sorry.
Wait, 3 and 12?
Yep, I'll do it on the side. And then plus x squared over 144
2 times.
And dx. Yes. So now let me do this. So for the middle term, we have 2 times 3 over x times x over 12. That's what we have. So x's cancel. 3 times 2 is 6 over 12, which is equal to 1/2. So negative 1/2. Because the sign was negative, the sign is negative. Are we all green on that? I wrote it in green. I can ask this way. Great. Now, the only thing I can do is to make it positive 1/2. Great. So this is going to be 9x squared plus 1/2 plus x squared over 144 dx. I added, why is this yellow now? Boom. Added these two, to create positive 1/2. Are we all agreeing on that? 1 minus 1/2 is half. Now what? All right, this is the $1 million step. Everyone, eyes over there, pens on the desk. You have to see this, otherwise you are doomed. If this is this, what would this be then? Exactly, it will be the same thing, well, just with a plus. Yeah, you get to compress it back.
Yeah, I guess so.
You get to just compress it back. So, this foils out into that, right? Now, if you compare these two, they're identical, except the middle term has a different sign. So if you were to squish this back into that, it will be with a plus then. These formulas have two flavors, one with a minus, one with a plus, depending on whether you are foiling a minus b squared or a plus b squared, right? So if there is a minus there, there is a minus here. If there is a plus here, then there will be a plus over there. So those algebra formulas are helping us condense this, and then that square would kill the root, and then it's easy to deal with the rest. So now we have integral 1 to 6 square root of open parenthesis 3 over x minus x over plus x over 12, everything squared, dx, and now we can cancel the square root and this. So what am I using here? I'll write the formula, and the formula says a plus minus b squared is a squared plus minus 2ab plus b squared. So this is the formula from your algebra class, and both of these with plus and with minus are used in this problem. So we expanded, and I can't remember the word now, we foiled, there we go. We foiled, right? We expanded this, and we got the one with the minus. So we were using this formula reading the minus. Now we have to go back, but now going back we have a plus, because this one and this 1/2 combined now into positive half. So now when we go backwards, it will condense into this one with a plus. So we go this way, we go back, using the other formula for other sign. And you have about 7, 8 problems like this to practice.
Why do we start
You?
put plus?
That's true, but what if it actually doesn't work to be a half?
I know, that's true. Yeah.
That's true, right? Those questions should come in with a little troll face next to it. But you see this function that is the vector field on the exam, 2 lines. Crazy. Calculate the potential function. Should probably take 10 days. Well, the answer is just the field is not conservative. It's a beautiful thing. Wait for Calc 3. All right, and now let's use this red. We cancel the square root and this little square, and we just integrate 3 over x plus x over 12 dx, which will give us 3 ln absolute x plus x squared over 24 computed from 1 to 6, which is 3 ln 6 plus 36 over 24 minus 3 ln 1, which is 0, minus 1 over 24. So this is ln of 1 is 0, so that dies. We have ln So 3 ln 6, you can leave it 3 ln 6. You can also put 3 inside. So 3 ln 6 plus 35 over 24. So that's exact answer. You can get the decimal if that makes you happy. It's fine. Good effort. Questions, concerns?
So on our exams, you'll be okay with that.
That's perfect, yes.
Okay.
All right, how about you have some fun? So your function is 2/3 x to the 3/2. Ooh, this is the one that I actually put on one of the exams. X to the 1/2. I can swear that this was on one of the Calc2 exams in the past. This exact problem. Procedure is the same. Get the derivative, plug everything in. You all have the same derivative? All right. Such is life.
Have your square root and
That would be
square
easier.
I don't know why you would x minus. Because if you have x half, since you're subtracting, it's going to be positive. Yeah. Yeah. Half x, 6.
Something like this.
Because half two terms are same. No. The x and the negative. Because that's to get power. That goes around half. 1/2 x plus 16.
Did anyone get 7?
7.
He's just messing with
Because that's wrong. Yes.
Okay.
Okay, let's take a look at this problem together. So we have the derivative already. We say that the length of curve is going to be from 1 to 9, square root, good effort, 1 plus x to the 1/2 minus 1/4 x to the negative 1/2 squared dx. Integral 1 to 9, square root of 1 plus. Now we have here, I don't need parentheses, just x minus, now x to the half times x to the negative 1/2 is going to be x to the 0, which is 1. So I just have a negative 1/4 times 2 is negative 1/2. Great. And then plus 1 over 16, x to the negative 1 over 16. Good effort. So now we have negative 1 to the 9, square root of, when we combine, we get positive 1/2 plus x to the minus 1 over 16 dx. Using the same trick as before, if this works that way, then when we go backwards, we will have a square root of, open parenthesis, x to the positive 1/2 plus 1/4 x to the negative 1/2, everything squared dx. At this moment, square root and square cancel, and we can take the integral of x to the 1/2 plus 1/4 x to the negative 1/2 dx. Now this is a basic integral. We have x to the 1/2 plus 1 would be x to the 3/2 over 3, and we put the half on top immediately, plus copy 1/4, that's a constant. Then we have x plus 1, sorry, 1/2 plus 1. Negative 1/2 plus 1 is going to be positive half, so x to positive half divided by 1, and then 2 goes on top. Computed from 1 to 9. This gives us 2/3 of x to the 3/2 plus 1/2 x to the 1/2 computed from 1 to 9. Perfect. These are all easy values now. We have 2/3 9 to 3/2 plus 1/2 9 to 1/2 minus 2/3 1 to 3/2 minus 1/2 1 to 1/2. Half means the square root, so we have 2/3. Square root of 9 is 3, so that's 27 over there, because 3 cubed is 27, plus 1/2, square root of 9 is 3, minus 2/3 and minus 1/2. So I don't want to cancel this, because if I do cancel, then I'll have to later work to get the common denominator, right? So 2 times 27 is 54, minus 2 is 52/3. And then this is 3/2 minus 1/2 is 2/2, which is 1, so plus 1. That's 3, so 55 over 3.
I did everything right until the addition at the end. I said 2 over 2 is 2.
I mean, plus 1, that's where everyone should trip in Calc 2 at the end. Plus 1.
Arithmetic, I don't care.
Nice. Perfect. Ta-da. You have to be extremely careful with this section. Do we all see this?
Technology.
What is that?
It's a T in a blue box. Letter T. Letter T stands for technology. So, when you set up this beautiful, easy problem 26, you are going to get absolute nightmare to integrate, which is why you are supposed to use technology. So, when you set these up, you can't integrate them. You did not learn any of the techniques yet or anything like that. So all of these will be very, very, well, impossible. So what you do is you use technology to come up with the answer at the end. You can use whatever technology. They're talking about hyperbolic cosine in problem 32. Hyperbolic cosine is going to be one of the hyperbolic functions that we are going to learn in chapter 7. So you haven't learned hyperbolic cosine yet. You will. But this problem is introduction to hyperbolic cosine already. So you can have some preview. So all of these problems, 10 through 20, you should be able to do them without any technology. So it's this trick or basic integration. When you hit the blue T, from that point on, you will have to integrate using software. And that's 6.5. Bye.